Hey everybody, this is Brian David Johnson. I am the guest editor for the IEEE Computer Magazine, the special issue on the world of making. And in this issue, what we wanted to do was to kind of look around the world and get a snapshot of what making is like in the year 2014. And we went lots of different places and talked to lots of different people who talked about biology and science and business and technology and entertainment, culture, education, and design. And the design part is really what our guest on the podcast today really kind of got into. We're really fortunate to have Nick Nakadate on. He is one of the contributors to the IEEE Computer Magazine on the world of making. So, Nick, thank you so much for joining us today.
Yeah, you bet. Thanks for having me.
So, Nick, you have got a really interesting background in architecture, but also in design. Really, what was your background, and how did you get into the world of making?
Well, I went to architecture school and got my degree, and it just all, at the time, things like AutoCAD were new. It was still DOS, and even some of the 3D programs that we use today were in just very early stages. But I knew that was something that really interested me. I trained traditionally, Mylar, vellum, pencil ink, all that. But also I knew that I had to keep up on this technology of CAD and computer-aided design. So it just became something where I kept rolling with that, keeping up with it, got hired on in architecture firms, and a lot of the skill I was used for was my design, but also design using computer technology to enhance it or help solve problems that would otherwise be extremely difficult or overly cumbersome to solve. I'd say it eventually I just really gravitated towards more of the design aspect of it, the art side, having all the art history training and whatnot with architecture school. That really caught my eye. So a lot of the design work and computer-aided design work that I did was kind of some of the more flashier things like 3D models in the computer, presentation renderings for projects or clients for existing projects or bidding on projects that we'd want to get in. And it just kept going from there. It's kind of the way I looked at it was, I wanted to learn. I want to learn this 3D modeling aspect of, say, AutoCAD, for example. It's like, okay, I'm going to stop there because I'm too busy. I've got too much other stuff to do. But then it's just this black hole. You step into the rabbit's hole, as it were, and you just keep going. There's not really any stopping once you go. So that's just, it sucked me in, and eventually I'm learning the 3D applications and just all this self-learning, because at the time there weren't really schools, or they're very, very early stages. So no schools for 3D animation, I should say, and that kind of thing. So I was learning that along with my architectural training and experience, which really has got me to it got me into the visual effects world and animation, and there's just this crossover of, the rendering graphics and lighting and color theory. All that crossover got me into film industry job, working on feature film and commercials, and then really to where I am today, where making's always been an important aspect of what I do. In architecture, I would do elaborate models, say, out of basswood, balsa wood, miniature lights, trees, all these things that, very, very tangible, whereas, the flip side, I'm also doing 3D CAD drawings and solving details in 3D with computer. But that's something, making has always been something that has been important to me and really fueled, my personal interest in creativity. So it's kind of like I always want to have my fingers in both of, the virtual world, but also the physical world, and how do those two come together? It's really keeps me going.
And so how did you get into building robots? I do have to say of your article, it has one of the best beginning lines, which is "Kids love robots." How did you get into building robots? And please tell us a little bit more about what you're making, what you're working on.
Mm-hmm. Yeah. Basically, well, my son Jackson is a super, super creative kid. I definitely see some of myself in him. We love to build Legos together. I would get in trouble when I was a kid for staying up until 2 or 3 in the morning doing that. I would secretly get up and start building. My dad would have to yell at me and make me go to bed. Jackson's very much, that way. But he would come up with projects and drawings like, hey, robots. And he'd just draw dozens and dozens of robots. And I was like, wow, this is pretty cool. How can I, encourage this and facilitate, him just keep going with his learning and feeling creative. Eventually, there came a day, actually, his school was having some issues, and we were worried it might close. It might be closed. And so I was like, well, what can I do to help as a parent and someone who wants to help out? Jackson hadn't started at the school yet. He's actually there now. So it was last year that we were looking at this. It's like, okay, well, what can I do? Well, I can do 3D. I can do animation. I can do modeling. So I thought, okay, let's combine those two along with the 3D printing aspect, which was, it's obviously in a very busy mode, very popular thing, and really taking up a lot of steam, and it has been. So I thought, okay, this is the way to get the virtual thing so off of paper and into a kid's hands, so they can have the creativity of, like, I made this, I drew this, and then also getting it into their hand, have it printed. They're part of the process, and they understand, well, this is what a robot, where it comes from. Because Jackson would say, he asked me, like, where do robots come from? And I'm thinking about it, well, presumably, what do I think about the future? Well, the future says we'll have robots. But it's where do they come from? And to me, it was like, well, everybody should be contributing to this, having a say in it, because ultimately the robots are there to serve us, we would think. And, we have obviously simplified versions of these now. But just the creativity of that and trying to help the school out, and just it's also very educational for the kids. So getting into, the classwork with the teachers and trying to implement that into art and science work that otherwise wouldn't necessarily be there.
And so what has it been like working with the kids and working with your son, showing them how to design robots and design them, on computers and design them in the virtual world, and then using the 3D printer to bring them into the real world? What have you seen? What has that been like?
I think there's a huge wow factor for the kids. They really get into seeing their drawing comes to life. Some of the younger kids can't necessarily draft or draw 3D. That's where I step in, or other artists, 3D artists, to bridge that gap. But it's also something, we try to stay true to the form of what the kid has put down on paper. But just to see then that transformation from just something flat to something very dimensional and tangible, it means a lot to them, and it's huge. I mean, just to see the smiles on their faces, they love it. I mean, it sounds pretty simple, but it's great to see, the looks on their faces. They're like, wow, this is amazing, and it means more to them. It starts to mean more than, this is a robot that I saw in a cereal box, and it's cool, or this is a ninja robot. They're designing all kinds of robots. From a robot that helps pick up toys or sports equipment in gym class, to a robot that escorts the bad kid to the principal's office so the teacher doesn't have to. Just a wide variety. So that was a nice thing, and that was one of the things I challenged them with is, along with the teachers, is what does this robot do for you? Because that's part of how they're going to evolve in the future for us and be designed. They have to have a function that really means something to you and is very helpful.
So where do you think all of this leads? I mean, you've mentioned as you go through it, it certainly brings, the tools of the future into, in front of kids, although they may not be doing some of the 3D design. They're watching it happen. They're getting introduced to it. I think that's one of the things, as I've been working with kids around robots as well, that to see how a robot is made, even how a robot is designed, kind of shows them that they can do that they have the ability to build a robot, that it's not something out of science fiction, and it's not something that, happens in big research labs or big universities, that it's something that people do, that people design robots and people make robots. Where do you see all this going? What's your hope for your project, that the effect that it might have?
I want to react to what you just said, and you're absolutely right. I think where this is going is partially what the kids see is they see those guts, they see the electronics, they say, oh, okay, it's not just a magic box inside, and it gets them interested in learning more about what that is and how they can do it. So it becomes more than just the shell, right? And it's the functionality, the mechanics, the electronics, the lights, the sensors, all that stuff. And so what I see that doing is really driving more creativity and technology and facilitating those things happening, of building more complex robots that would help us and building things that are just smarter, because they're using, to me, I've always believed in, you need a lot of creativity to go with all that technology, because they really should just go hand in hand to get the best out of both worlds. But I see that the kids are going to be doing more of that. Like maybe we've got hopes that for classes that the older kids will be the ones helping the younger kids 3D model. So cross-generational things happening, and even say with adults or seniors that want to do work with kids. Like how does that affect things? Like maybe does the senior have an idea that no kid would ever think of? Things like that. But really just expanding, past the shell of the robot that most people see, and understanding that they can contribute to it and the guts of it. And I think that's where being able to build these things and also pull them apart, the kids are going to see all the different areas in which they can work. So it's not just limited to certain things. And I think it really opens their minds up and their to, hey, I can do more. It's not just, doctor, fireman, policeman. I can be, it's going to be way more popular to be an electrical engineer per se, or, a computer programmer or somebody to write software for robots. You're writing artificial intelligence. So I think they're exposed to so much more, and it just leads to so much more creativity and possibilities for our future workforce.
Right. It's a great project. And thank you so much for joining us on the podcast today, and for your article in the World of Making IEEE Computer Edition. And if people want to get more information about Builtbot, where should they go?
Go to the site builtbot.com, and we're also have a presence on Facebook. There should just be more news getting out there as things move ahead. I'm just hoping that it keeps spreading along with the school districts. It just keeps going. So, but the builtbot.com is a great place to start.
Awesome. Well, Nick, thank you so much again for joining us, and we look forward to see what robots you and students build.
Great. Thank you very much.